Okay, so in today's lesson then we're going to go through the sides of a right angle triangle. So in a triangle they have three sides. Now from the last lesson we've already identified one of the sides, which is the hypotenuse. So we know that the hypotenuse is the longest side and also the side opposite the right angle. Okay, so the other two sides then, one would be called opposite and the other one is called the adjacent. Now you label the sides, it's in relation to the angle that you're talking about. So in this triangle here, they're talking about the angle A. Now the opposite side is the side that is opposite the angle that you're talking about. So it's A here, so then the opposite side would be here. Adjacent means next to, so then the adjacent would be the side of the side of the triangle that is next to or adjacent to the angle. So looking at this example here again, so it's the same shape, right angle triangle, but this time we're talking about the angle up here, B. Now the hypotenuse doesn't change, it is the same on both triangles because the hypotenuse we know is opposite the right angle. So for B then, the two other sides that we have to label is opposite. So our opposite is down here this time because it has to be opposite the given angle. So the opposite side to B would be this side. And then this side here would be called the adjacent because it's next to the angle. So the three sides are labelled either hypotenuse, which is opposite the right angle, the opposite, which is opposite the angle that we're talking about, and adjacent means next to the angle that we're talking about. So then we're going to do this example here. So we'll have to label each side. Okay, so it's either adjacent, opposite, or hypotenuse. So we'll do the hypotenuse first because we're used to this one. So that's the one that's opposite the right angle. So the one opposite the right angle would be the 5. So that would give me 5 then would be my hypotenuse. Okay, the 3 then we can see is directly opposite or across from the angle which we're talking about, which is A. So that 3 would be known as our opposite. The 4 then we can see is the last one. So we've done opposite, we've done hypotenuse, so it has to be adjacent, and adjacent means the one next to the given angle. So 4 then would be known as our adjacent. Okay, so again, we're just dealing with labelling sides of a triangle. So question 1 here, it says write down the length of the hypotenuse in each of the following triangles. So we know that the hypotenuse is the one opposite the right angle. So in the first triangle, the hypotenuse would be 10. In the second one, it's opposite the right angle, so it would be my 5. And then it's opposite the right angle in my third example here, which will be 13. So remember, the hypotenuse is always opposite the right angle. So just identifying sides of a triangle. Part 2 then, they said write down the side adjacent to the angle A. So adjacent means next to. So in the first one, it would be 8. In the second one, it would be 4. And the side next to the angle A in the third one would be 12. So I'll just do A for short. So A for adjacent, 4 is my adjacent here, and 12 is my adjacent in the third one. Okay, question 3 then is write down the length of the side opposite the angle. Okay, so opposite the angle here would be 6. So that would be opposite. Opposite the angle here would be 3. So 3 would be my opposite. And opposite the angle in the third one, opposite the given angle, which is A. So 5 would be my opposite there. Okay. Okay, so moving on then from labelling a triangle. So it's important that you label a triangle very carefully. The opposite, opposite the angle, the hypotenuse, opposite the right angle triangle, and the adjacent, the side next to the angle. Because we're moving on now today to trig ratios, okay? So in your course then, or in the trigonometry course, you have 3 ratios, and it's the sine ratio, the cosine ratio, and the tangent ratio. So in each triangle, the ratio opposite side over the hypotenuse is the same, that is 0.4. So the ratio opposite side over hypotenuse is called the sine of the angle. And we use SIN instead of using the SINE. So for a sine of the angle A here, or sine of any angle, it's the ratio opposite side all over the hypotenuse. Moving on then to the cosine rule. Okay, so in the given right angle triangle, the ratio is adjacent side all over the hypotenuse. It is called the cosine of the angle A, but we use cos, C-O-S is used for cosine. So the cos of the angle A is adjacent side all over the hypotenuse. The tangent ratio again, so in the given triangle, in the given right angle triangle, the ratio opposite side to adjacent side is called the tangent of the angle A. And we use tan is used for tangent. So tan is the opposite side over the adjacent. So the sine is opposite over hypotenuse, the cos is adjacent over hypotenuse, and the tan is opposite over adjacent. Okay, so the sine, cos and tan is actually given in your formula and tables book, and it's on page 16. Okay, so on page 16, this is what you'll be given. So they give you the right angle triangle. So we have the angle A. So A, that side A would be our opposite, B would be our adjacent, and C would be our hypotenuse. So they said sine A is A all over C, which is opposite over hypotenuse. Cos is adjacent all over hypotenuse, which is B all over C. And tan A, which is A all over B, where A is the opposite all over the adjacent. They also give Pythagoras' theorem. Okay, so there's two sayings then that we use that you find it easier to learn what sine, cos and tan is. So the first one is silly old Harry caught a herring trawling off America. So you take the first letter in each word. So like in the first sentence, we'll have silly old Harry. So we'll take the S, the O and the H, and that would stand for sine, which is opposite over hypotenuse. And then in the next line then, you're going to do the C, A and H, which will stand for cos. And cos is adjacent all over the hypotenuse. And then, I'm just going to move this down. And then in the third line then, you're going to do trawling off America. So we take the T, O and A. So that will stand for tan, which is opposite over adjacent. Okay, so it would be like silly old Harry caught a herring trawling off America. So another one then that he tend to do, you like down here as well, is Sakatoa. So you kind of just learn the saying Sakatoa. So again, the S-O-H stands for sine, opposite over hypotenuse. Cos is adjacent over hypotenuse, and the tan is opposite over adjacent. So Sakatoa. So again, you can learn it those ways, or you have it in the log tables, and you just have to be able to apply it. Okay, so just going through an example of that. So we have a triangle. So we have the angle A. So they've highlighted the angle A. So that's what we're doing with. We have 5, 12 and 13. So they asked us for the sine A, cos A and tan A. So before you do that, I always get you to label the sides of the triangle. So we always have to label it in relation to the given angle, and the given angle was A. So opposite A is 5. So 5 would be my opposite. So OPP then is your opposite. Your 12 is the next to the angle, so that would be my adjacent. So 12 then would be adjacent. And then the 13 then is opposite the right angle. So the 13 then is the hypotenuse. Okay, so they want you to get sine of A, cos of A and tan of A. So for the first few questions, I want you to always write down the ratio. So sine A, we know it's opposite over hypotenuse. So opposite would be 5 and the hypotenuse is 13. So we get 5 all over 13. Cos A, so cos of any angle is the adjacent all over the hypotenuse. So the adjacent is 12 and the hypotenuse is 13. And tan of A, the ratio is opposite over adjacent, and the opposite is 5 all over 12. So for all of these questions, the first step I want you to do is always label the sides, then you must write down the ratio and then fill it in. Okay, so we'll do another example. So it says, from the given triangle, write down the value of sine A and cos B, etc., tan A, tan B, etc. Okay, so remember we have to label our sides in relation to the given angle. So just for this one, it might be easier if we just draw out the triangle with A. Okay, so this would be A. So A then is 1, would be opposite, the hypotenuse is 2, and the square root of 3 would be our adjacent. And then we're just going to label that. So that would be our opposite. 2, because it's opposite the right angle, would be our hypotenuse, and the square root of 3 would be our adjacent. Then I'm going to draw out it again for B. So B is up here. We still have the same values, 1, 2, and the square root of 3. But this time in relation to B, so in relation to the blue angle, the root 3 is the opposite. The 1 would be the adjacent, and the 2 would be the hypotenuse. Okay, so then filling in the first one, then they asked us for sine of A. So sine of A. So sine of A is opposite over the hypotenuse. So the opposite is of in A is 1, and the hypotenuse is 2. So that would give me 1 all over 2. Next one is the cos of B. Okay, so the cos of B, so we're down cos of B, always write down the ratio, so it's adjacent all over the hypotenuse. And then we go to B, so the angle B, and the adjacent is 1, and the hypotenuse is 2. So that would give me 1 out of 2, 1 over 2. The next one then is tan of A. So we'll do tan of A. So we know tan is opposite over adjacent. So looking at A then, so opposite is 1 and the adjacent is root 3. So that would give me 1 all over root 3. Next guy is cos of A. So cos of A, so cos is adjacent all over the hypotenuse. So adjacent of A is root 3 all over the hypotenuse is 2. So give me root 3 all over 2. Then we have tan of B. So tan is opposite over the adjacent. Tan of B then, so we're going to go to our B. So B is opposite is root 3. All over adjacent is 1, which is root 3. All over 1, which is simply root 3. And then the last one then we have is sine of B. Okay, so sine of B is opposite over hypotenuse. Looking at B, opposite B is root 3 and the hypotenuse is 2. So that would give me root 3 all over 2. Okay, so this question here then combines everything that we've done so far. So we must use the theorem of Pythagoras to find the side marked x. Then we have to label our sides of a triangle, and then we're going to have to write down the sine A, cos A, and tan A. So the first thing that we're going to do is we're going to use Pythagoras theorem. So we know that Pythagoras theorem states that the square on the hypotenuse is equal to the sum of the squares of the other two sides. So filling that in then for this question, that would give me 15 squared is equal to x squared plus 12 squared. Then that would give me 15 squared minus 12 squared is equal to x squared. 15 squared is 225 minus 12 squared is 144 is equal to x squared. That would give me 81 is equal to x squared. So x is equal to the square root of 81. So my x is equal to 9. So drawing out that triangle then again, I can fill in that my x now is 9. My hypotenuse was 15, and they had given me my adjacent, and then we have our A. So we're going to label our sides again. Okay, so here's my right angle. So the 15 is the hypotenuse. The 12 would be my adjacent because it's next to the angle, and the 9 would be my opposite because it's opposite the given angle that we're talking about, and we're talking about A. Okay, so then they want us to find sine of A, cos of A, and tan of A. So dealing with sine, first of all, so sine of A. So remember, always write down the ratio. So sine is opposite over hypotenuse. So if you did silly old Harry, so O stands for O and Harry stands for the hypotenuse. And then you just simply fill in. So opposite A we said was 9 and the hypotenuse is 15. So the sine of A then would be 9 all over 15. Okay, cot a herring. Okay, so cot a herring is cos. which is adjacent all over the hypotenuse. The adjacent is 12 and the hypotenuse is 15. So that would give me 12 all over 15. Trawling off America, okay? So the trawling will stand for the tan, okay? So the T will stand for tan. I'm just writing the tan, okay? And this would be cos. So it was tan is opposite over adjacent. Opposite A is 9, all over the adjacent is 12, to give me the ratio 9 all over 12.